All right, so this is Mr. Hendrickson here, and I'm giving you guys a quick run through on how to perform the calculations for the angled projectile portion of this lab. So yesterday, you should have already done the initial velocity of your rocket by doing the vertical rocket portion of this lab. So I'm just going to go ahead and say that my initial velocity of my rocket is 25.0 meters per second. And I'm going to go ahead and use an angle here of 40 degrees, okay? So given that information here, we should be able to go ahead and start by first finding our components. And then once we have our components, we can go ahead and find the total time in the air. And then part 3 would be just finding the range. This is really no different than what you would do on a angled projectile test question or any of the practices we've done up to this point. So please make sure you're also referencing your notes here as we go. So first, to find our components, you have to understand, of course, that we know our total velocity here is 25.0 meters per second, and we know that our theta is going to be 40 degrees, and therefore we can solve for our Vx and our Vy. And again, the trig identities here are Vy is V sine theta to solve for our vertical component. So Vy is going to be 25.0 meters per second times sine of 40 degrees for me. And again, I go ahead and I throw that in my calculator, making sure my calculator is in degree mode. In this case, I do get 16.1 meters per second for my Vy. My Vx is going to be V cosine of theta. So Vx is going to be 25 meters per second times cosine of 40 degrees. So I'll put that in my calculator as well. And I get 19.15 meters per second there for my Vx. So we'll round that to 19.2 meters per second. Okay, so there's our components there. Now that we have our components, we have everything we need to do part 2 of our lab here, which is just to find the total time in the air. Okay, and again, of course, we know that when we reach the top, our y velocity is going to be 0 meters per second, which allows us to use Vfy equals Viy plus at. The velocity at the top is 0 meters per second. Our initial y velocity was found here using our components. We know that to be 16.1 meters per second. And then we're going to add in our gravity here. We're going for accuracy here. So let's go ahead and use 9.8. We're going to use negative 9.8 because it's acting the other way. And then time is our unknown piece. So we'll go ahead, rearrange, solve for time. We get negative 16.1 meters per second equals negative 9.8 meters per second squared times t. And then divide negative 9.8 in both sides. And we will have our time, which in this case is 1.63 seconds. Now we're looking for total time, so it's 1.63 seconds to the top. So we need to go ahead and take 1.63 seconds times 2, and we will get, let's see, approximately 3.26 seconds for our total time in the air. And lastly, how far we go, our range is our dx. And of course, we know that there is no acceleration horizontally, so we do know that dx is Vx times t. And so with dx being our unknown, our horizontal velocity is over here. We know that to be 19.2 meters per second, and our time, total time, is 3.26 seconds. So we'll simply multiply those two together, and in this case, we're going to get a horizontal range, in this case, of 62.6 meters. Now, we are going to take this and we're going to go out on the football field, and if we go out on the football field, we are going to need to make sure that we have the conversion of meters to yards, because a football field is obviously measured in yards. So the other thing we're going to need to know is that 1 meter is 1.094 yards. So we can go ahead and use that conversion with this dx here and go ahead and convert to yards. So I'm just going to do some factor label here, 62.6 meters times 1.094 yards per 1 meter. And we should get, let's see, times 1.094. I should get approximately here, let's see, 68.5 yards. So if you're lucky, you can make me stand 65 yards away from a goal line and fire in towards the center of the football field. And if there's no wind and no air resistance and everything comes together, maybe, just maybe, you'll even hit me. Good luck. Make sure your work looks like this, and do not forget that there are questions on the back. Please make sure you take the time to answer those as well. Good luck, and I'll see you on Monday.